Hello everyone, my name is Shashank, Master Teacher of Mathematics at Vedantu. Here we are presenting solutions for JEE Advanced 2019, Paper 1. Question for this video is, let's have a look. It is related to the topic quadratic equation, but it's a good problem. See, let alpha and beta be the roots of x square minus x minus 1 equal to 0 with alpha more than beta. Alpha is the bigger root. For all positive integers and define an, here they are defining an as alpha raised power n minus beta raised power n upon alpha minus beta, n greater than or equal to 1. B's are defined as b1 is equal to 1 and bn is an minus 1 plus an plus 1 for all n greater than or equal to 2. Then which of the following options are correct? When we look at the option A and B only, are concerned to the values of A's. In option C and D, B's are taken. B's are required to be checked. So question looks lengthy, but I'll show you how can we easily find these, check these options correctly and quickly. Coming to the first option, a1 plus a2 plus up to an is equal to an plus 2 minus 1 for all n greater than or equal to 1. We have to check whether it is correct or not. I'm writing, see, yeah, I can write, yeah, a1 plus a2 plus an is equal to, yeah, sigma alpha raised power n minus sigma beta raised to the power n upon alpha minus beta. Now sigma alpha raised power n ranging from 1 to n, so we can write alpha plus 1 using the formula of sum of a GP. I can write it as like this, right? Now in order to tackle alpha minus 1 beta minus 1, I'll go back to the quadratic. As alpha is a root, I can write alpha square minus alpha minus 1 is 0. So then I can write alpha into alpha minus 1 is equal to 1. So I can write 1 upon alpha minus 1 as alpha. So from here we can easily get whatever we need to check, like this, and here you are getting alpha power n plus 2 minus beta raised power n plus 2 divided by alpha minus beta minus alpha minus beta divided by alpha minus beta, which is nothing but an plus 2 minus 1. So option A, the same right hand side was there, option A is correct, an plus 2 minus 1. Getting it? Yeah, option B, it looks like infinite GP, an upon 10 raised power n, and an is defined. Yeah, so an upon 10 raised power n. See how can we check option B. An sigma an upon 10 raised power n, and from 1 to infinity, an was defined as alpha raised to the power n by 10 raised power n minus sigma beta raised power n by 10 raised power n divided by alpha minus beta, right? And n ranging from 1 to infinity, it is nothing but infinite GP, every term of the numerator, and we can write use the formula for infinite GP, like first term upon 1 minus common ratio, a upon 1 minus r. So I can write alpha by 10 upon 1 minus alpha by 10 over here, and minus beta by 10 upon 1 minus beta by 10 over here upon alpha minus beta. So I am solving it in a usual manner. So I can write again alpha upon 10 minus alpha, I think, minus beta upon 10 minus beta upon alpha minus beta. So further we can write 10 times, yeah, 10 times alpha minus beta, okay, and right, okay, what we are getting here, right, minus alpha beta plus alpha beta you'll get upon 10 minus alpha 10 minus beta, and yeah, alpha minus beta is also there. So these two got cancelled, and alpha minus beta will also be cancelled from numerator and denominator. In numerator you will get only 10, and in denominator if you open it, or using the factor theorem we can say that it is nothing but p of 10, isn't it? So I mean 10 upon, it is 10 square, right, it was, the equation was x square minus x minus 1, no? Minus x minus 1. So it is 10 upon 100 minus 11, that is 89. 10 upon 89, and I think the same thing was given in the right hand side. So option B is also correct. Coming to option C, this is very interesting. Option C, Bn is equal to alpha raised power n plus beta raised power n. Is it correct? Now Bn is defined as an minus 1 plus an plus 1, and an is defined besides the Bn, in the left of Bn, we have been using in the option A and B. So Bn, how can we say that Bn is alpha raised power n plus beta raised power n? Is it true or not? Let's see. Option C I'm taking. So Bn actually was defined as an minus 1 plus an plus 1 for every n greater than or equal to 2. So can I write it as alpha raised power n minus 1, okay, minus beta raised power n minus 1 by alpha minus beta, plus alpha raised power n plus 1 minus beta raised power n plus 1 by alpha minus beta. See, how can we easily get the option C? Yeah, so I can write alpha raised power n 1 by alpha plus alpha, right? Then minus of, okay, plus of beta raised power n, right? Yeah. Okay, minus 1 by beta minus beta divided by alpha minus beta. I'm trying to make alpha raised power n plus beta raised power n. You should also again check the right hand side of option C, alpha raised power n plus beta raised power n. Now, as the equation was x square, keeping in mind x square minus x minus 1 equal to 0. Yeah, so can I say the product of roots is minus 1? So 1 by alpha can be written as minus beta, and similarly 1 by beta as minus alpha. So I can write alpha raised power n minus beta plus alpha plus beta raised power n. Now minus 1 by beta would be alpha minus beta upon, I'm not changing the denominator. We are keeping denominator as it is. Finally alpha minus beta will get cancelled, and we'll get alpha raised power n plus beta raised power n. So option C, you can see in this manner, is also true, isn't it? Yeah. Now coming to option D. Option D can again be found using in the similar manner what we have adopted to get the option B, Bn upon 10 raised power n. However, by giving little stress to the mind, we can see that Bn would be, we can easily show it that Bn is more than an for every n, and except n equal to 1, where both are same. After n equal to 1, Bn would be greater than an. So sigma Bn upon 10 raised power n will also be greater than sigma An upon 10 raised power n. So option D must not be correct, because already An upon 10 raised power n sigma is 10 by 89. So option D, Bn upon 10 raised power n must be more than that. more than 10 by 89, it is given 8 by 89, lesser than that. But okay, we can I mean, this is something which we must give a proper definite solution. It's not like that we just are observing it and not giving the proper strong idea about it. So for that we'll have to, there's no difficulty in finding the option D again. So Bn upon 10 raised power n sigma n upon 1, and from n equal to 1 to infinity can again be written as a Bn just we have found that Bn is alpha raised power n upon beta raised power n. So I can write like this: sigma beta raised power n upon 10 raised power n, ranging from 1 to infinity. Again using the formula of infinite Gp, alpha by 10 1 minus alpha by 10 plus beta by 10 upon 1 minus beta by 10. So you'll get then alpha upon 10 minus alpha plus beta upon 10 minus beta over here, and then we can easily write here it is nothing but P10 when you take the LCM, and in the numerator you'll get 10 times alpha plus beta, right, minus, okay, here it was beta, sorry, right, minus alpha beta minus alpha beta, so it is minus 2 alpha beta. So alpha plus beta here is 1, and alpha into beta is minus 1, and P10 is 10 square minus 10 minus 1. So finally you will get the answer to sigma Bn upon 10 raised power n as 12 upon 89, but in option it was 8 upon 89. So option D must not be true. I think it's clear to you. So this can be the easiest way to get all these options, to check all these options. I hope you understood the solution. Again the typed, so ABC were correct, D was not correct, as you can see here. The typed solution is also here. Maybe at some step there is some difference what I have explained in this question, in this video. So you may go through it, almost similar. Okay, take care, stay tuned for the next question. Thank you.